Hello, my name is Oscar, and I will be showing you how to find the area under or between two curves with a GDC. So first thing you will need is this GDC, and so to show you guys this, I will be using two examples as two IB questions. So here they are, just so you can see. Exactly, so it's calculate the area bounded by the curve of, then there's a function as shown in the diagram below, and find the area enclosed between the curve, also a function, and the line and another function. And so I will just be drawing this on my board. Okay, so the first question is I have to find a1 here and a2 here. This is x equals 0, x equals 1, and x equals 3. This is the function. It's f of x equals x to the power of 3 minus 4x to the power of 2 plus 3x here. And to do so, we will be using our GDC. And the first thing you want to do is pull up your formula sheet, because we will be using this formula. For example, so we will try to find 0 to 1 and 1 to 3. So we will first find a1 and then a2, and we will be using this formula. We will plug in 0 here, 1 here, here's a smaller value, and here we put in our function, and here it should be dx. And so when we're doing this with the calculator, you want to press math 9, and we will be able to see this formula, and now we just have to plug it in. So I plug in here 0, then up here 1. One sec, I'm just plugging it in. So it should look something like this. Yep. So now we press equal, enter, yes, enter, and we come up with our first value for a1. So a1 equals 0.41666, but we will be just using the three first significant figures, so 0.417. So looks like this. And so for a2, we will do the exact same thing, and to find both areas, we will just add them together. So again, math 9, and we will and then we always have to look at these intersections here at 0, 1. So the intersections with the x-axis, they're really important, and you will be using those. So we put in, as a smaller value of the x intersection, we will put in 1, and as the bigger one, we will put in 3, because the area is right between there. And we will plug in the same function again. So it should look something like this. Then we press enter, and we will come up with a negative value. But since it can't be negative, we will just we will multiply this with -1, and we will come up with the positive value, because this is the one we will need. So it's 2.67, again, three significant figures. And yeah, so that's a2, and now we will, just to show you guys, a2, a1, and now we will add these two together. This is our final solution, and to show you guys on the calculator, this is our final solution. Okay, so next up, we will find the area enclosed between the curve f of x equals x squared minus 2x minus 3, and the line f of x equals x plus 1. So to do so, we would like to do the same thing as here again. And to do so, we would have to find the x-interceptions of the two graphs. So exactly. So we will have to use our calculator for this, and we will have to go to y equals, and yeah, and then we just plug in as y1. We plug in x squared minus 2x minus 3, and x2 equals x plus 1. So and then we have to click graph here, graph. So yes, as you can see, we have those two functions. I'm just going to draw them on again on my. So to find the enclosed area, so the enclosed area is all this entire closed area. We will have to find these two intersections of these two graphs, and we will use our calculator for this because we need the enclosed area. And yeah, and the other intersection is 0. We'll again do two areas. So we will call it again A1 and A2. And yeah, so we will exactly, and to find the intersection, we go to second and calc. Okay, we will go there, and then we'll go to number 5, which is intersect here. So 5 intersect, and we will, so the first curve, exactly, you just look for the first and the second curve, and you will come up with the intersection. So intersection point is, we're just interested in the x value. So x is -1, so it's -1 here. And the second, so we do the same thing again. So first curve should be here, always as close as yeah, so x equals 4. So yeah, so we will first find this of this graph, and then we will add the area of the second graph. And so we will find first this area as A1 with this function, and then we will find this second area with A2. So we have our x-interceptions now, and now we plug it into the calculator and use the same formula again but now we will first find A1 with the second function. So, and we will come up with 12.5. So we have our first value for A1, and our second value for A2 is again math 9 and in the calculator. And then we go from -1 to 4. And then we plug in the second function. And now we, of course, come up with a negative value again, but we will multiply this by -1, and we come up with 8.33. And yeah, so those are our A1s and A2s. And now to find the entire enclosed area, we will just add them together. So 12.5 plus 8.33 equals 20.8. 3 significant figures. So 20.8 here. That's our final value. And yeah, thank you. That's it with my tutorial, and I hope I could help you guys.